Alright, section 4.2 is on the second form of a quadratic, standard form. In 4.1 we talked about vertex form. So today we're going to start with standard form, which is y equals ax squared plus bx plus c. We're going to learn how to graph those functions, and then we're also going to learn to change them into the vertex form that we used yesterday. Before we do that, I've got some practice problems here of things that you want to know how to do mentally and not have to write out. So here I've got some algebra skill review of expanding what's called a binomial squared. It's a binomial because there's two terms here, x and 5, and we're going to square. If you want to square a binomial, here's what the pattern looks like. You square the first one, and you will square the last one. Some people make the mistake that, oh, I should just distribute and then we're done. That's not it. There's two terms in the middle. If you were to change this into a plus b times a plus b, you'd end up with an ab and then another ab. So you end up with two of the same thing. So there's the generic pattern for a binomial squared. We want to be able to apply that here. So the first term is x, so we square that. Then what we want to do is take 2 times the two terms, which are x and -5. And I would do this mentally. I'm just showing you how it is. But I'm going to take 2 times, and I'm using minus. Oh, I should have put plus here, excuse me. Mistakenly used minus. I put a negative over here. That took care of the minus. So I treated that like -5. So I want to take 2 times each of the two things individually. Well, that ends up being minus 10x. So I would just do x times -5 is -5x, times 2 is -10x. And then you do the last one squared. And the last one is -5, so you're always going to get a positive at the end, because -5 times -5 is positive 25. So let's do it here. First one squared, x squared. Then I need to multiply these, that's 3x, but I double it to get 6x. And then it's the last one squared. First one squared, 3x times 3x is 9x squared. Multiply these, I get -12x. Double -12x, that'd be -24x. And then -4 squared is plus 16. Final one, you might want to pause right now, give it a shot, see if you get it right. 5x squared is 25x squared. 5x times 2 is 10x. Doubled is 20x. And then finally, 2 squared is 4. Okay, well, why did I want us to practice the skill today? Because I wanted to look at the vertex form of a quadratic, which we went over yesterday. And what's the vertex form? Well, that's that y equals a times the quantity x minus h quantity squared plus k. And the vertex was hk. H was the x coordinate of the vertex, k was the y coordinate. So let's expand that out. So what do I mean by that? I mean, let's get rid of the parentheses. So to get rid of the parentheses, I would do x minus h squared, and I would just apply what we did above. First one squared is x squared. Multiply these, and I get -hx. But I need to double that, so it's 2hx. So it's minus 2hx. And then finally I square the h at the end, the -h, and I get positive h squared. Well, I still don't have the parentheses gone. I need to distribute this a. So I'd have ax squared minus 2ahx plus ah squared plus k. Well, that might look kind of confusing to you. That's a lot of letters. Well, there's a reason I'm doing this, and we're almost there. Now I ask you, what's the coefficient of x? Hang on, I'm trying to get my screen back there. Okay. What's the coefficient of x? Coefficient is the number or the term in front of x. So that'd be -2ah. What's significant about -2ah? It's in the same place that the b is in our standard form above. Standard form has an a in front of x squared, You might notice that A is the same as A here. And B is in front of X. So therefore, negative 2AH has to equal B. This is in front of X. This is in front of X. The rest of this stuff doesn't have an X by it. So that's really the same thing as C. AH squared plus K is C. Now, I don't care about that right now, but I'm just saying it doesn't have an X, so that's the same as C. Well, what's kind of cool then is if I get H alone here, and I should have put solve for H right here. I got to fix that in my notes. If I get H alone, I divide by negative 2A. I find out that H is the same thing as negative B over 2A. And remember, that's the X coordinate of the vertex. So when I'm in standard form, I don't have an HK staring me in the face, but I know what the same thing, or what's the same thing as H. And what's the same thing as H? Negative B over 2A. So that's what we're using today. We're going to start by graphing the vertex, just like we did with vertex form, but we have to do negative B over 2A first. So that's what I have up here. Some common things, A is greater than 0, then it opens up, just like vertex form. If it's negative, it opens down. The axis of symmetry is x equals negative b over 2a because the x coordinate is at negative b over 2a. Now, people tend to struggle finding the y. All you got to do then is plug in, this is what that means, plug in your negative b over 2a into the equation. So when I say f of something means plug that in. So whatever answer you get, plug that in. Whatever answer you get for the x coordinate, plug that into the equation so you can get the y. Now, how do I get a y-intercept? Well, y-intercept means what's when x is 0. So if I had y equals ax squared plus bx plus c, and I plugged in zeros for x, hopefully see that what would be left would be c. So that last number is the y-intercept. So let's show you how we would graph this when it's in standard form. First, we'd identify A, B, and C. So on my one I have here, I got A is 3, B is negative 12, and C is 4. Now we're going to find the vertex. Well, the vertex, again, we start with negative b over 2a. So here, negative b over 2a would give me positive 12 over 2 times 3, which would be 12 over 6, which would be 2. And again, that stands for the x-coordinate of the vertex. How do I get the y-coordinate? Well, I get the y-coordinate by plugging it into y equals 3x squared. I'm going to just take the x out. Minus 12x, take the x out, and add 4. The 2 over a little bit or down here a little bit. So here again, there's my vertex. So I'm taking this 2 right here and I'm just plugging in for x. I'm going to do the math and see what that turns out to be. The first term would be 3 times 4, 12. 2 squared is 4. Then it would be minus 12 times 2, 24, plus 4. So I'd have negative 12 plus 4. I get a vertex of negative 8. So 2, negative 8. So let's go down and graph that, 2, negative 8. Well, I went down to negative 7, so I guess it's right here. There's 2, negative 8. Then I said find the axis of symmetry. Well, that's a vertical line that goes through that vertex. And the axis of symmetry, step number 3, would be x equals 2 on this one. Find another point on the graph, step 4. Well, another point on the graph is simply the y-intercept, and the y-intercept is that last number. The y-intercept is the last number of 4. If I plug in 0, I get 4. So that would be 0, 4. That's right here. And then I can reflect that over the axis of symmetry. This is 2 away. This dot right here is 2 away from the axis of symmetry. So I can move it 2 over here. And now I've got 3 points, and I can draw my parabola. Maximum min, just like yesterday. What's the, this one has a minimum because it goes at a bottom point, so it has a minimum of -8. And the domain on these parabolas, they go forever left and right, so our domain is always going to be all reals. And then the range goes with the y. The y bottoms out at -8, so you could say all reals greater than or equal to -8, or you could say y is greater than or equal to -8. Right? Second problem, write the standard form in the standard form equation in vertex form. Well, we want to write in vertex form. Let's start by writing it down. Y equals a times the quantity x minus h quantity squared plus k. And remember that we need a, h, and k, and then we're in vertex form. Well, yesterday I gave you h and k, so it was easy to find. I just plugged those in. Today, a is the easy thing to plug in. A is 2. A over on the left is going to be the same as a over on the right. Now I need to find hk. How do I find hk? Well, I know that h is the same as negative b over 2a. H in vertex form is the same as negative b over 2a in standard form. So, negative b. Well, b is 8, so negative b is negative 8. Over 2a. 2 times a is 2, so we have 2 times 2. Negative 8 over 4 is negative 2. Turn around and plug that in so that you can find the y. And in front I get 8. Negative 2 squared is 4, times 2 is 8. Minus 16, 8 times negative 2 is a negative 16, minus 1. So that'd be negative 8 minus 1, which is negative 9. So the vertex is at negative 2, negative 9. How do I represent a negative 2? As an x-coordinate, I need to put x plus 2. It's the opposite, squared. But the k is the same. There's vertex form. This would be a parabola that bottoms out at negative 2, negative 9. Opens up. If I wanted to graph it, I could find the y-intercept, which would have to be negative 1. That's that last number. And then there would be a negative 1 over here. So that means there's a minimum. The minimum is negative 9. The domain's always all reals on these parabolas because they go forever left and right when they open up or down. And the range would be all reals that are greater than or equal to negative 9. Here's another one for practice. You could try this one on your own. Make sure you understand it. So I pause right here, give it a shot. Now I'll go through it. Here's my vertex form. I know a is negative 5. Now I need to find the vertex. I need to do negative b over 2a. That gives me the x-coordinate. B is negative 2, so negative b is 2. A is negative 5, so 2a is negative 10. 2 times negative 5, negative 10. That reduces to negative 1/5. That means over here I'm going to have an x plus 1/5 squared because that is the x-coordinate of my vertex. Now, during class we went through this, people are having trouble plugging in negative 1/5, so be very careful here. It would look like this if you're going to do it by hand. The square goes on the outside. And put the negative 1/5 in parentheses, otherwise you can punch it straight in your calculator. Negative 1/5 squared is 1 over 25. Negative 2 times negative 1/5 is positive 2/5. So I'd have negative 5 over 25 plus 2/5. Let's put the 5 on top right here. It's like 5 over 1. So that'd be negative 1/5 plus 2/5, because 5 over 25 reduces to 1/5. So my k is 1/5, and that's what goes at the end of my vertex form equation. What's the axis of symmetry? That goes through the x-coordinate of the vertex. So that would be x equals negative 1/5. What's the domain? All reals. What's the range? Well, this one has 1/5 as a boundary. That's right here, 1/5 is a boundary. But remember, this one has a negative in front, so it opens down. So this one actually is all reals less than or equal to 1/5. This one has a maximum of 1/5. Okay. And finally, got a word problem here. On my word problem, it's in standard form. And I just want to find the max height of a ball. So here's what's going on. I've got someone throws a ball from 5 feet in the air. So I'll just say this is 5 feet right here. They throw it up, it comes back down. I want to know this spot up here. So I just want to know the vertex. Just want to know the vertex. Move it off right here. Move my axis over a little bit. So find the vertex. We're just going to do negative b over 2a. So we get negative 60 over negative 32. B was 60. A was negative 16. So 2 times negative 16 is negative 32. If I divide that out, I get 1.875. That gives me the x-coordinate. That's 15/8 or 1.875. Now I got to plug that in so I can find the y-coordinate. So it'd be negative 16 times 1.875, or I could do 15/8 squared plus 60 times 1.875 plus 5. Okay. So we run that through our calculator. I'd had a better time doing this by hand if I would have used the 15/8. Just making a quick calculation here because I don't have the answer memorized. Okay, 61 1/4. 61 1/4. So that tells me my vertex. My vertex right up here is at 1.875 and 61 1/4. Sorry for that mess there. That's 61.25. Well, the graph told you that the height is basically based on the time. So over here I have height, and that's measured in feet. And down here I have time, and that's measured in seconds. So it's at its highest at 61.25. Please tell me feet. Because is it miles, is it meters? I don't know. You got to tell me feet. I didn't say how many feet. I said what's the max height. So you have to tell me feet. How long does it take to reach there? 1.875 seconds. Finally, I got one more question. When will the ball be 5 feet from hitting the ground? So I want to know how long does it take to get over here where it's 5. And what I'm getting at here is think about the axis of symmetry and think about what's supposed to happen here on my graph. My axis of symmetry is a little out of whack, but it's right in here. This should be the same as that if they're symmetrical. Because this is also at a level of 5, and I want a level of 5 over here. So when they're at the same height, they should be the same distance from the axis of symmetry. So if you want to get this, all you have to do is double the 1.875. You get 3.75 seconds. Telling me that it's going to take a little bit over that to hit the ground. Because we only got 5 more feet to go. That concludes our lesson. Thanks for watching. Have a great day.